All right, the next couple of lessons, you're going to play around with some complex numbers and see how they relate to vectors or how they can be represented with vectors. And again, I say complex because they exist. And hopefully I'm going to kind of convince you more that they do exist. So the first thing I'm going to look at is a new coordinate plane. I haven't labeled anything yet because it's going to be labeled a little differently. So think of this syllabus right here as the normal plane you're used to, with the x coordinates this way, y coordinates this way. Well, I could turn this thing in different directions. I mean, it's a plane, so I could turn it through 3 dimensions if I'd like. And if I turn it completely sideways, it should look like a line. I'll get the camera angle right. And that's what's going on here. So imagine every xy coordinate you're used to graphing existing on this plane, but yet it's been turned sideways. And this is it right here. This is the real coordinate plane. We're just going to see it as a line because it is turned sideways, but that's the real numbers. That's all real numbers you're used to. And if you remember what we've talked about with complex numbers, for every real number that exists, decimals, fractions, anything you could ever imagine, there's another complex number that goes with it. A simple way to think about that is just attach an I to the end of that number, and it's now complex. So if there's this parallel plane, kind of think of it as x coordinates and y coordinates, but each one has an I attached to it because it's complex or lateral, then that plane is turned on its side as well, just maybe rotate a different way. And this is the plane that holds all of the complex, or all of the lateral numbers, the numbers that just have the I with them, which you probably heard called imaginary, but they're not. So we're going to put the little I there as a symbol for that. So what you really have here, that was a 2-dimensional plane this way. This is a 2-dimensional plane. If you keep track of all that, that's a 4-dimensional space. So it's kind of hard to wrap our head around. That's why we're just going to represent it with a plane here, with a new plane, 2-dimensional. Okay. So that's what you're going to be operating, this new complex plane with real numbers on the x-axis and lateral numbers on the y-axis. So how do you graph in that? Okay, so let's take a complex number, 5 plus 3i. So if this is our real axis, we go out 5, because that's the real number part. And if this is our lateral axis, we go up 3, because it's 3i, plus 3i. So over 5, up 3, and from the origin to that point, you're now representing that complex number as a vector. We went over 5 and up 3. And all the rules you've been doing with vectors, you can now do the vector math with this complex number right here and represent it that way. Then you're going to do some things where you add them and multiply them and see what the results are. And vectors are going to kind of show you, I think, what's happening when you do those operations. All right, just a quick reminder. Let's suppose you have 2 complex numbers multiplied together. You can treat the lateral I just like any variable. So we can FOIL it. 5 times 1 is 5. 5 times 2i is 10i. 3i times 1 is 3i. Now this one's plus 6i squared. Now don't forget, if you have I squared, that's the same thing as negative 1. So that's saying 6 times negative 1, so that part's really minus 6. We can put these together, that's 13i. And then just 5 in the beginning. So 5 plus 13i minus 6, 5 minus 6 is negative 1. And there you go. Negative 1 plus 13i. That's how you would represent this complex number when you multiply them together.